Unit 3, Lesson 5, maximum and minimum values of a quadratic function, or finding the vertex. Okay, so when you are asked to find the vertex, there's going to be a few different steps based on what form the quadratic is in. However, there's usually 3 steps that you have to follow, and if you're given a quadratic in a certain form, you might be able to skip one of the steps. You're going to factor to find the zeros, then use those zeros to find the axis of symmetry, and then use the axis of symmetry to find the optimal value, or the y value of the vertex. And then you put the axis of symmetry and the optimal value together to form the vertex. So let's go ahead and calculate the vertex in each of these 3 examples. So example 1 is given to you in factored form of a quadratic already. So this would be an example of where you can skip step 1, because we already know that the zeros are at 1 and 10. Okay, so let's skip right to step 2 and calculate the axis of symmetry. You're just going to add the zeros together and divide by 2. Let's find the optimal value next. So we're going to plug in the axis of symmetry into our original equation. Okay, so therefore the vertex of this quadratic is at 11 over 2 and 81 over 2. Okay, example B. This one's really easy because it's already in vertex form. So we know that in vertex form, the coordinates of the vertex are your P and Q values. Okay, this last one is in standard form, so this is going to take the most work. We actually have to go ahead and factor this first. So we need 2 numbers whose product is 45, and the sum of those 2 numbers is 14. So your answer is going to be 5 and 9. So let's go ahead and plug those in. And then let's factor by grouping. Okay, so you know that your zeros are at negative 5 over 3 and negative 3. So now you're going to find your axis of symmetry. And now you're going to find your optimal value by plugging in 2 over 3 into your original equation. And you're going to get a final answer, once it's reduced, of 77 over 3 for your optimal value. So therefore, the vertex here is at 2 over 3 and 77 over 3. So we learned about completing the square in the last lesson. There's another method that you can use to figure out the vertex called symmetry or partial factoring. And basically it's a shortcut version of completing the square. So here are the steps to partial factor. So first, set your equation equal to the C value. So our C value here is 10, so I'm going to set my equation equal to 10. Okay, then let's simplify the equation. So we'd bring 10 to the other side, okay, so that we can combine like terms. We're going to get 0 equals 3x squared plus 15x. Step 2 is factor A and the variable x from your A and B terms. So our A value is 3, and factor out an x. We're left with x plus 5. And now let's find our zeros from that. So our first 0 is equal to 3 minus 3. So our first 0 is 0, and our second 0 is -5. Okay, now let's find our axis of symmetry. Okay, and let's find our optimal value. Okay, so therefore our vertex is at -5/2 and -35/4. Okay, let's complete our square for the second one. So we set our equation equal to the c value. And then we simplify, so we can combine our -25 with the other 25 on the other side, and they cancel out. And then we factor out our a value and an x from the first two terms. Okay, now let's find our zeros. Now let's find our axis of symmetry. And let's find our optimal value. So therefore our vertex is at 8 and -41. Okay, so that's how you use partial factoring to find your vertex. Okay, I want to formally review completing the square with you guys because you're going to use this a lot. So completing the square is what helps you to transform a quadratic written in standard form into one in vertex form. Let's go ahead and convert this quadratic from standard form into vertex form by completing the square. So I've listed the steps, so this should be very easy for you to follow. So step 1 is factor the a value out of the first two terms. So we're going to factor the -2 out of the first two terms. Okay, the second step is figure out the value you need to add and subtract into those brackets to complete the square. And you do that by following this equation. You take your b value, divide by 2, and square it. So our b value is 6. So I'm going to go 6 divided by 2 and square it, and I get 9. So the next step is take that value and add and subtract that value into your brackets. So here I go. I'm going to add and subtract 9 to my brackets. Okay, the next step of completing the square is use distributive property to take the negative term that you use distributive property to remove the subtracted term from the bracket. So I'm going to go ahead and multiply my -2 times my -9 to bring it outside of the brackets. Okay, now I'm going to go ahead and simplify. And now we've created a perfect square trinomial inside of those brackets, so we can go ahead and factor that. Okay, and now we have our quadratic in vertex form. So we know that our vertex would be at -3 and 21. So knowing how to complete the square is very important because it helps you to take a quadratic from standard form into vertex form, and then you can easily identify the vertex. So I would like you to now try completing the square to determine the vertex of the following 4 quadratics.